Drop it.
Welcome back to another video. In this video, I'm going to demonstrate another implementation of a two-dimensional array in Java. Now, as you can see on the screen, it's asking us to enter the order of matrix. So let's enter a 3 by 3 matrix. Now let's input 9 elements. So you have the elements here. As we press enter, it shows to us the given matrix here, and it determines the smallest and largest value. After determining the smallest and largest, we also see here the location where that particular value is located. So number 1, which is our smallest element, is located at row 1, column 1, while 9 here is present at row 3, column 3. Let's have another input. Again, let's try a 3 by 3 matrix. Now, same, we have 1 at the smallest and 9 is the largest. But if you notice here, now the number 9 is located at row 3, column 1. So let's now go and see our program. So the first section of our code is our variable declaration. By the way, I think I don't need this one. I just copy and paste the previous program that we had. Okay, so we have the following variables. I and j will be used for the loop. M and n will be for the order of matrix. A will be for our array. Then I have here a series of variables. Small for the smallest, lar is for the largest, row small, column small, row large, and then column large. Okay, so those are the meaning of those variables. Then we prompt the user to enter the order of matrix, which we will store in our variables n and m. So we prompt the user to enter the order of matrix, and then we input our matrix here, or we input our array. Okay, now this is how we do, let's say, determining the largest and smallest value. The item here is that we will assume that the first element, let's say row 1, column 1, will be the smallest value, same with the largest value. Row 1, column 1 will also be the largest value. And then we will somehow assign the following value, let's say 1, to our row small, column small, row large, and column large. That will be our point of reference when we do the comparison. If we will not do this one, we cannot identify whether which of the following values that we entered is the smallest element. So in order for us to do our comparison, assume that the first element here, row 1, column 1, will be the largest and smallest value for point of comparison. Now we go look at this section here. So in this section, we will have to display our given matrix. Now we will also look at the smallest element. Now since we have set here that the smallest value will be located at row 1, column 1, we will be comparing the values to our array our array here with the values, let's say the location I and then j. If we identify that that is the smallest value, what we're going to do is we're going to store that particular location, small is equals to ai, and then set the row small and then the column small to the value where we found the smallest number. Same goes with this line here. What we're going to do is this section here identifies whether if the largest is less than the array that we have. Then if we found that that is the largest, then we're going to store the values here, and then we're also going to store the location on that particular array. So this will be the largest value here, and then for the row, and this one will be for our column. Then this section here just prints out the smallest value, and then the row and column together with the largest value, and then the rows and columns where we found that particular largest element in our array. So if we run our code again, let's have one last example here. Okay, now let's go to our output window here. So let's input again a 3 by 3 matrix. Then let's input any element. Okay, now, so we have here a random set of numbers. The smallest number here, found out that 1 is the smallest, which is located at row 2, column 1, and 99 is the largest, wherein we locate it at row 3, column 3. So here's another array implementation of a two-dimensional array in Java that looks for the smallest and largest value together its present position in our matrix. So that's all for today. Thank you for watching. Bye.